So what we're going to be starting today is Chapter 5. Chapter 5, Rational Expressions, Rational Exponents, and Rational Functions is what we're going to be looking at today. Now, we're not going to get all the way through Chapter 5 before spring break because we only have 4 today and 3 more days this week and then 4 days next week. So we'll get through about half of it. We'll take a big quiz on Thursday before we go on break, and then we'll come back and finish. Now, looking at this here, which one is greater? That actually is the square root. So this here is the square root of 2. Now, we don't normally write the 2 in there, but it is the square root of 2. So what is the square root of 64? 8. What is the cubed root of 64? 4 times 4 is not 8. 16. And 16 plus 16 is 32, and 32 is? So it is the square root, or the cubed root of 64 is 4. Because 4 times 4 is 16, and 16 times 4 is 64. Yeah, we actually, the 32s that we did, because we just ended up multiplying it by 4, because 16 and 16 is 32, so that's 4, or 16 times 2, and 32 plus 32 would give us 4. It's almost really, and this works out with all of them, that the bigger the root that we take, the smaller that the number gets, because we're trying to find what number times itself. For square root is 2 times, for cubed root is 3 times. So the more roots, so the bigger the roots we have, the more that it's going to be multiplied by itself that we're looking for. Now this here is key. The nth root of a, I'm going to just go on and do the x, is equal to a to the x over n. Whatever power a has goes on top. Whatever the root is goes on bottom. And what this is really telling us is that any radical, any nth root, you can rewrite as a fractional exponent. Yes. And we could do this with the cubed root of 64. So we'd have 64. Well, what exponent is with 64? 1. Because since there's not 1 written, it is going to be 1 over what? So we're taking 64 to the 1/3 power. So we're multiplying it by itself 1/3 times. Now 64 is 4 to what power? 4 to the 3rd, because 4 times 4 is 16. 16 times 4 is 64. So 64 is 4 to the 3rd, yes? Now, powers and powers multiply. So 3 multiply on top. What's 3 divided by 3? Well, we could have done this the other way and said the cubed root, well, we said 64 is 4 to the 3rd. And what have we always said? The cubed root and cube powers will, because really we can rewrite it as a fractional exponent. For this here would be 3 over 3. And we know that 3 divided by 3 is 1. So they simplify out. This is why when the index of whatever the root is and the exponent match, they cancel out. This is why that works. All right, let's look at these here. So we have square root of 9 equals 1/2. Right. Okay. Oh, okay. I was trying to remember what we were doing here. We're just really trying to show that this is true, that these do equal. So what we could do is we can use a calculator to figure this out. So if you have a calculator in front of you, take the square root of 9. Well, we know what the square root of 9 is, don't we? So the square root of 9 is 3. Now in the calculator, figure out what 9 to the 1/2 is. It's 3, yes. Mm-hmm. Let's do it with the square root of 2. So we can do the square root of 2. When you get that, tell me at least the first 3 decimal places. 4. And 2 to the 1/2 is? Should be 1.414, yes? It's a non-repeating, non-terminating decimal. Yeah, 1.5 would give us something a little bit bigger than 2. It's weird. It's weird how it works out. So we can see here that both of these work out to be the exact same, yes? That our fractional exponents and radicals give us the same thing. Now we can evaluate these here. There's 2 different ways we can do it because we can plug these into the calculator and get our answer. So the square root of 5 cubed, well, we could type this into the calculator, square root of 5 in parentheses cubed, and it would give us our answer, which is, it's going to be a decimal. 11 point what? 11.180. All right, we could plug it into the calculator. Now, the TI-84s are nice, except if it wants it in simplest radical form, because I think it gave you something different, Eric. Okay, it gave you the decimal version of it? Okay. Because sometimes it'll give you the radical version, which, as we just said, I could rewrite this as 5 to the 1/2 cubed because of our property with these radicals. Because the exponent with 5 is 1 and the index is 2, because for radicals, the index, if it's not written, is understood to be 2. And if we multiply it by 5, we get 5, or to the third, powers of powers multiply, would give us 3/2. Well, 3/2 is the same as what? 1 and 1/2, yes? 3/2 is 1 and 1/2. So that means I have 1 whole and half. So what they could say is that I have a whole 5, and the half would be the square root of 5, because these would be the same thing. Questions on this here? We can do this here, the fourth root of 4 squared. And what would be the fourth root of 4 squared? It would be 2. It would be 2. Because really what we have is 4 to the 1/4 squared. Right? Because 1/4 times 2 is 1/2. Because 1/4 times 2 would be 2/4. And 2/4 simplifies to 1/2. And 4 to the 1/2 is the same as the square root of 4, which is 2. And that's it there.
So basically, it's the number you come up with 3, it's not.
Not always. Because say if this was 6, the fourth root of 6 squared doesn't work out as well. It just worked out here that it does work well. And we have these here, and most of these are just, I mean, we can do these here. The cubed root of 9 squared. Well, this would be the same as what? 9 to the 1/3, because again, the exponent with 9 is 1. And the root is 3, so we'd have 9 to the 1/3. Now, powers of powers multiply. So we can take this as 9 to the 2/3. And this is most likely going to give us a decimal. Yeah.
I like these, but I also know very well that this could easily create something hard.
We get this decimal. Now, if we wanted to actually keep it in radical form, it is possible. Because again, when we look at this here, the 2 is squaring the 9, and then we're taking the cubed root of it. Because if I turn this back, because we'd have this here, the cubed root of 9 squared. The number on top is the exponent. The number on bottom of the fraction is the root. Now, 9 squared is what? 9 times 9 is? 81. And when we look at cubed roots, we're trying to find a number that multiplies by itself 3 times for it to simplify, yes? Well, 81 is actually what? 3 to the... Because 3 times 3 is 9, times 3 is 27, times 3 is 81. So to make it look a little bit better, well, we could say 3 to the 3rd times 3, which would be 3 times the cubed root of 3. And it would give you the same answer. So there are other ways to manipulate these and find the answer. Let's do one more of these, and then we'll move on to the next type, because we can plug in, if using a calculator, evaluate the 5th root of 10 to the 4th. What'd you get? Okay, we just have to type it in. Now, if typing in the 5th root of a number is a little difficult, well, what could we type this in as? 10 to the what? 4/5. Yeah, okay. No, you're good. Because we should write it as this first, and then 10 to the 4th. 6.309, yes. 5/4 might be that.
Yeah, 5/4. That's fine.
Mhm.
Wait a minute.
Yeah, so you need to be careful because the root
Goes
should
to the bottom.
should be on bottom.
Add profit. Stop.
Root should be on bottom. Questions on this here? I think we are good with these here, yes? Let's do 2 of these here. Well, if we want to evaluate 8 to the 2/3 or 6 to the 5/2, we can do that either by hand or with a calculator. Now, 8 to the 2/3, this might be a little bit easier to just type it in because we can just type this in and get the answer, which is 4. Now, that might seem odd. How did we get 4? Well, 8 is 2 to what power? 2 to the 3rd, yes? And this is to the 2/3. Now, we said powers of powers multiply together. So 3 times 2/3, well, 3 times 2 is 6. 6 divided by 3 is, and 2 squared is 4. So on some of these here, if we can reduce it, it helps to get us to the answer. But the calculator will do the exact same thing. Is there any way that I can rewrite 6 as a number to a power? Well, no, the only factors are 2 and 3, yes? So we can't rewrite it. So this one here, we're just going to have to plug it in. 38.181. Well, it makes sense because 5/2 is what is a decimal? It's 2.5. 5 divided by 2 is 2.5. So 2.5, so we're taking 6 to the 2.5. So it's not just doubled, it's doubled in a half. So it should get bigger. For the one before, we took 10 to the 4/5. Well, 4/5 is less than 1, isn't it? So it should get smaller.
So we basically square roots are just like the power is just times 8 by itself. So times 12 is 9.
For this here? Because really, let's look at it back as a radical. Because this would be the square root, because 2. And then inside we'd have 6 to the... So what is 6 to the 5th? So we're trying to see what number multiplied by itself is this here. So that's kind of why we get a bigger number, because the number itself is getting bigger. 6 is getting bigger. Any questions on this here? All right, that's more of the same thing, more of the same thing. Still more of the same thing. Okay. Sorry, this here is, I was skipping through it thinking it was. Now there's a slight difference with these here, and we'll look at these next 4, because I don't think we have much more after this. Actually, I think these are, except for the next part, these are kind of the last ones. These here, we want to evaluate each expression with what? Without using a calculator. Now, the main difference is that these here do simplify. Because if we look at 4, can we rewrite 4 as a number to a power? 4 is the same as what? 2 to the 2nd power. And for the ones that are using without a calculator, that's what we're looking for, is can we rewrite these numbers as a number to a power? Now, powers of powers multiply, so we do the 2 times the 3, because it always multiplies on top. 6 over 2. Well, 6 divided by 2 is And 2 times itself 3 times is? Well, 2 times 2 is? 4 times 2 is? 8. And that's how we do these without a calculator. So 32 is going to be what? So 4 to the second?
Wait, no, wrong. Sorry.
Well, we can do the prime factorizations for 32, because I do know it's 2 times 16, yes? 16 is 32. Well, 16 is 2 and 1.
Wrong. Wait,
2 and 8. 8 is 2 times. And 4 is, well, what do we have? 1, 2, 3, 4. The 32 is the same as 2 to the 5th. 2 times itself 5 times is 32. Now we can multiply this. 5 times 4 is 20 over 5. And 20 divided by 5 is? And 2 to the 4th would be?
That's recount. I think I'm saying everything wrong today.
And that's what we can do here. So we can do this with any number, not just 2. Like if we look at these here, 625.
No, something times 5 goes.
So I would agree, 5, yes. So we divide it by 5 first. So this would be 125. And if we do it again, we get, so it'd be 1, 2, 3. Yes. Because really we can look at this as 4 times 3 fourths. Well, the 4 and 4 would cancel. And 5 to the 3rd is 125. Because 5 squared is 25, and 25 times 5 is 125. Okay. Let's do another one. 49 to the 3 halves. What can I rewrite 49 as? 7, because it would be what? 7 squared. 7 squared is 49. Wait a minute. It would be 2 times. Right? Because it would give me 7 to the 6. It would give me 7 to the 6 halves. 6 divided by 2 is 3. Now 7 to the 3rd. I'm wanting to say 320, 343. Mm-hmm. Yeah, you would have to write these out, do 49 times 7 to get there. Okay. Any questions on anything we've covered thus far?
No.
Okay.
I think I get better at that.
Let n be an integer such that, let n be an integer, n is greater than 1, and let a be a real number. If n is an even integer, and a is less than 0, no real nth roots. Okay, so what this is saying is I have a radical. Let n be an integer greater than 1. So n is our root, whatever root we're taking. And a is the number inside the radical. So this one here, n is even. That means n is divisible by 2. So we either have a square root, a fourth root, a sixth root, an eighth root, going and so forth. Now, if a is less than 0, what does that mean? A is negative. Can we take the square root of a negative number? Well, we can. It just won't be what?
It'd be an I.
It'd be I, which is
Imaginary.
imaginary. We wouldn't have any real roots. So it's not real roots. Now, if a is equal to 0, well, it would be,
Zero square root is 0.
I mean, no matter how many times we multiply 0 by itself, it's still 0. So no matter what the root we take of 0, it will be 0. Now, if a is greater than 0, we will have 2 real nth roots, and it'll be plus or minus the nth root of whatever it is. And what they're really saying is that, like, the square root of 4 is 2. And what we're looking at is not just saying that, it's more we're taking the square root of 4, or square root of that squared, and we get this plus or minus because of the root and the power. Now, if the root is odd, so cubed roots, fifth roots, seventh roots, ninth roots, and we take the odd root of a negative number, it's just whatever that number is, because we can take an odd root of a number, odd root of a negative number. So the cubed root of, so we could take the cubed root of negative 27, because 27 is 3 times 3 times 3. Because a negative times a negative is a, times a negative is a negative. So an odd number of negatives will become a negative. So we can do it with odd roots, odd sets of multiplication, odd number of the times itself, but we can't do it with even. So the only one that's really different is this here. We can take the odd root of a negative number. We cannot take the even root of a negative number. And here, if we take the even root of a positive number, we have this plus or minus, whatever it is. And if we take the odd root of a positive number, we only have 1. So if we take the odd root of any number, we're going to have how many solutions? 1. If it is even, we either have no real roots, 1 real root, or sometimes I can't even with this, but that's kind of how this works, okay? So these last few here, I most find these actually not that bad. Find the indicated nth root of a. So we're looking at the nth root of a. So for letter A here, what's the nth root? What root are we taking? We're taking the cubed root of 216. So is the root even or odd? Odd, because the root is 3. The root, when we talk about the root, is the number that goes inside that little V shape. This here is our root. Now, since it's odd, we can take the odd root of any number, positive, negative, or 0. I want to plug it in. No, I just barely got ahead of you.
I'll get there.
So since it's an odd root, we can take any number of it. Here, we're going to take the what? Root of? We're taking the fourth root of 81. And the fourth root of 81 would be? Almost. Mm-hmm. And it would be plus or minus. Because if we're taking the fourth root of that there, if we're going backwards, it could be positive or negative 3. Now, if we're just looking at the fourth root of 81, it would be 3 because we can't take the negative. But dealing with this here, we're almost looking at it kind of x to the fourth equals 81 is more than. Yep. Yep. Well, we'll find one here. Yep, this here would be the fourth root of 16. And the fourth root of 16 would be? We have plus or minus 2. How about number 2 here? Because we'd have the second, or the square root of negative 49, yes? Right, so this is no real root because this would be 7. No, double R. Any questions on this here? Are we good with this here? Yes? I feel like y'all are good with these here, yes? Don't need another example of one of these? Okay, which one? The fifth root of 243? I kind of gave you that answer, but since we know n is 5, we're taking the fifth root of 243 because that's our a. Now in the calculator, we can do 5 fifth root 243 and hit, and it comes out to 3. Since it's an odd root, we don't have to do the plus or minus. Now, if you're trying to do these online or kind of do them on a calculator that doesn't have these roots, because I think most calculators just do square roots, they don't deal with these here. Well, because we'd have 243, because I would put it in parentheses, caret, because I can rewrite this as what? It'd be 1 divided by, I don't know what the actual name of that is. I'll need to look it up, but I just call it a little caret because it looks like a caret. So if it doesn't have the ability to do these radicals, we can do this here, which is telling it this is the exponent, this number to the 1 divided by 5 power, which is essentially telling it that we want 243 to the 1/5, which is the fifth root of 243. That's it. I don't know. Questions on this here?